Okay, my friends, so this next topic, the normal distribution, we've actually mentioned this a number of times as we've gone through the course, but I'm going to kind of imagine that we haven't yet and kind of show you how it shows up organically as we look at other stuff. And that's one of the reasons we're going to be learning about it at this point in the course, is that it does show up so frequently. And those of you going past this class into, say, Math 244, or even going into other courses like psychology or sociology or things like that, you'll see it time and time again there. We just got done the binomial distribution, spending a lot of time with that one. And that's just one of many distributions that you've seen in this course. Most of the ones we looked at didn't have names because, honestly, named distributions, well, I'll show you what named distributions look like. This is how I learn statistics, and I've been very, very cautious not to let, you know what, get this thing out of here. Not to let you see that, because that's not the way to instill kind of a curiosity in students, to show them a bunch of formulas. But there are a lot of useful distributions. Now, when I say useful, useful for whom? That's why we've looked predominantly at distributions as a whole, then in particular the binomial, and today we'll get into the normal. And I want to get more detail into the normal next, but I want to show you how this thing just kind of pops up as we go. Let's take a look. Okay, my friends, so we're going to take a little trip back in time now. What we're going to do is we're going to roll some dice. Just like we did throughout this course, we've talked about rolling, I think we've rolled up to 3 dice, and we're gonna do that again here. We're going to let Excel do it for us. That saves us, well, I wish we were in class together and we could roll these dice together, but we can't. So what I'm going to do is I'm going to use Excel to roll a certain number of dice for us, and we're going to start with 1 here. So I'm just rolling a single 6-sided die, and I'm keeping track of the results over there to the right. Okay, you notice there's a little bit of a lag there with the 6s, but now the 6 is on the board. So what I'm going to do right now is I'm going to hold down this F9 button and let it do its thing. All right, I think that's probably enough. I mean, I guess we can keep, what the hell, I'll let it run while we talk some more. So, you've probably noticed what's happening, which is exactly what you thought would happen. This is why we use dice, because this happens right here. So this particular distribution that you get has a name, and I probably mentioned it at some point. It's called the uniform distribution, okay? And it's a special one. It basically, a coin flipping is an example of a uniform distribution. Any single die being thrown, no matter how many sides, is an example of a uniform distribution. It's what happens when an equally likely outcome can happen a number of times. So the 6-sided die is kind of the most prevalent of those. Okay, so uniform distribution has nothing to do with the bell curve, right? Right. Unless you start rolling more dice, and that's where it gets interesting. I'm going to lift up my little F9 holder downer here, and I'm going to skip over to 2 dice. What does it look like when you roll 2 dice? And I'm just going to let this thing do its thing. I'm going to let it roll and let it keep rolling, because these probabilities have stabilized. If you look super carefully at this while we're randomizing, every once in a blue moon you'll see one of the probabilities change a little tiny bit, but they've pretty much stabilized now. Now, I still wouldn't call that a bell curve. That right there is a triangular distribution. In other words, there's not really a curvy bell shape to this. It literally goes up and then comes back down linearly on both sides. But it's a vast difference from the uniform distribution back here. Now this one over here definitely has a symmetric shape left to right, but it's definitely not uniform anymore. So why? Well, as we studied a few weeks ago now, I guess, the reason the 6, 7, and 8 in the middle are peakier than the 2 and the 3 and the 11 and the 12 on the end is simply because there's more ways to get those. Okay, what happens when we start rolling even more 6-sided dice? So let's shift over now to 3 of them. Now what you're beginning to see now is, unlike the previous one, let me click in here and get rid of some of that, there we go. unlike the previous 2 dice example, where these sides went up and then came down, you're beginning now to see on this one that there's a bit of a curve. It starts curving and then it seems to steepen and then curve across the top. These are beginning to take on a different shape. What started so innocently as just a rectangle became a triangle and now is beginning to morph into something else. Now let's flick over here to 4 dice. So, let me actually bring this graph over a little bit too. It's a little hard to see. There you go. So you begin to see that the sums are dispersing wildly. From 1 die, we started with only 6 outcomes. 1, 2, 3, 4, 5, and 6. Now when we roll 4 dice, and we're talking about the sum of all 4 of those, the smallest roll we can get is a 4. And according to this, we haven't seen many of them, but we've seen it a little bit. And the largest roll we can get is a 24. That would be all 6s. But now you're really starting to see that smooth curve appear. And it gets more pronounced with 5 dice. There's 5. I had to make it a little bit smaller, but I will make the graph a little bit bigger so we can see. Matter of fact, I'm going to cover up the sum and then drag it down here. There we go. That'll be easier to see. And you can really see that bell curve kind of appearing here. So what started so simply, what started as just a single die rolling, has become something much, much larger. It went from, as we said before, a rectangle to a triangle to these beautiful curved shapes. And I want to talk a little bit today about other places this shows up besides dice rolling. Because what's happening here in the background of this spreadsheet, what's being kept track of by Excel right now, permeates quite a bit of that which occurs in our daily lives. We'll get into that in the next video.